Have you ever gazed up at the night sky and wondered if somewhere out there, something is looking back at us? This question has tantalized humans for centuries, sparking curiosity and driving countless adventures into the cosmic unknown. The universe is staggeringly vast, a sprawling expanse of stars, planets, and galaxies that stretches beyond our wildest imaginations. In this vastness, the idea that Earth is the only planet with life seems, statistically speaking, improbable. Today, the search for extraterrestrial life is more than just science fiction. It's a dynamic field of study backed by serious scientific inquiry and cutting-edge technology. As we explore this topic, we'll delve into several scientific insights and theories that suggest life might exist beyond our lonely planet. From the discovery of exoplanets that mirror our own to understanding life in extreme conditions here on Earth, the evidence is mounting. Let's dive into the evidence that may prove we have distant cosmic neighbors. Imagine worlds beyond our solar system, orbiting distant stars. These are exoplanets, and their discovery has been crucial. Exoplanets, short for extrasolar planets, are planets that orbit stars other than our Sun. The first confirmed detection of an exoplanet orbiting a Sun-like star occurred in the early 1990s, and it dramatically shifted our understanding of the universe. Suddenly, the cosmos was not just a vast expanse of stars and void, but a potentially teeming neighborhood of varied worlds, each possibly cradling life. Now, you might wonder, how do astronomers find these distant worlds? They can't simply use a telescope to take a snapshot. Instead, they use a few ingenious methods. The most prolific of these is the transit method, which involves observing the slight dimming of a star as a planet passes or transits in front of it. This tiny dip in brightness can tell scientists a lot about the planet's size and orbit. Another method is radial velocity, which measures how a star wobbles due to the gravitational pull of an orbiting planet. This wobble can reveal the presence of a planet and offer insights into its mass. One of the most famous tools in the Exoplanet Hunters Kit is the Kepler Space Telescope. Launched in 2009, Kepler was designed specifically to find Earth-sized planets in the habitable zones of their stars. Regions where temperatures could allow for liquid water, a crucial ingredient for life as we know it. During its mission, Kepler identified thousands of exoplanets, enriching our understanding of the universe's complexity and diversity. Among these discoveries are some standout candidates for habitability, such as those orbiting the star TRAPPIST-1. This system contains several Earth-sized exoplanets, some of which reside in the star's habitable zone, stirring up exciting discussions about the possibilities of life. The existence of countless exoplanets suggests that the conditions for life are not unique to Earth. The sheer number of planets hints at the incredible possibility that, somewhere in the vastness of space, conditions just right for life have emerged not just once, but perhaps thousands, if not millions of times. Life on Earth thrives in the most unexpected and extreme environments. Imagine organisms that not only survive but flourish under conditions that would be fatal to most life forms. These hardy survivors are known as extremophiles. They are the mavericks of the microbial world, pushing the boundaries of what we consider habitable. Take, for instance, the tardigrades, often affectionately called water bears. These microscopic creatures can survive temperatures as low as -320 degrees Fahrenheit and as high as 304 degrees Fahrenheit. They can withstand the vacuum of space, extreme radiation, and even the crushing depths of the ocean. Their resilience makes them a prime example of life's potential to endure extreme conditions. Then there are the extremophiles that dwell near hydrothermal vents on the ocean floor. These vents spew scalding water rich in chemicals toxic to most life forms, yet they are bustling with life. Organisms here rely not on photosynthesis but on chemosynthesis, drawing energy from chemical reactions to thrive in perpetual darkness. Such examples on Earth have profound implications for extraterrestrial life. Consider Mars, with its sub-zero temperatures and radiation-swept surface, or the icy moons of Jupiter and Saturn, which harbor subsurface oceans beneath their frozen crusts. The existence of extremophiles on Earth suggests that life could potentially adapt to the harsh environments of other worlds. Moreover, the discovery of extremophiles has expanded our understanding of the habitable zone beyond the traditional scope of Earth-like conditions. It's no longer just about finding a planet with the right distance from its star, but also about considering the potential for life in environments that are radically different from our own mild climate. If life can flourish in Earth's harshest conditions, why not elsewhere in the cosmos? How do scientists use mathematics to estimate the odds of extraterrestrial civilizations? Enter the Drake equation. Formulated by astronomer Frank Drake in 1961, this equation isn't just a formula, but a way to ponder the probabilities of finding intelligent life beyond Earth. The Drake equation breaks down into several factors. First, it considers the rate of formation of stars suitable for the development of intelligent life. Not all stars are created equal after all. The equation asks how many stars in our galaxy have planets. These celestial bodies are not just twinkling lights but potential homes for alien civilizations. Next, it looks at the fraction of those planets that could potentially support life. This is where things get really intriguing. Life, as we know it, requires certain conditions. But as we've seen in our own solar system, life can surprise us by thriving in environments we once thought were inhospitable. Then, the equation considers the fraction of planets where intelligent life actually evolves. Intelligence is a tricky variable. It's not a guaranteed outcome of life. Furthermore, the equation estimates the fraction of civilizations that develop technologies that release detectable signs of their existence into space. Each factor in the Drake equation introduces more uncertainty. The number of civilizations in our galaxy could be 0, or it could be teeming with life. The vast range of estimates reveals more about our own assumptions and limits of knowledge than definitive answers. While it's filled with uncertainties, the Drake equation opens our minds to the statistical likelihood of alien civilizations. Science never sleeps, and the quest to find extraterrestrial life is more vibrant than ever. In the recent past, we've made some thrilling strides in space exploration and discovery. One such notable discovery is the detection of organic molecules on Mars by the Curiosity rover. These molecules, essential for life as we know it, suggest that the building blocks for life may have once been present on the red planet. This finding fuels speculation that life could have existed on Mars, or perhaps still does in some form under its surface. Meanwhile, our gaze has also turned to the icy moons of our solar system, particularly Europa, one of Jupiter's largest moons. The Hubble Space Telescope captured compelling evidence of water vapor plumes erupting from Europa's icy shell. Why is this exciting? Because beneath that ice could be an ocean, and where there's water, there might just be life. This tantalizing possibility has made Europa a prime target for future missions. Speaking of future missions, let's talk about what's on the horizon. The James Webb Space Telescope, launched in December 2021, represents a giant leap forward in our ability to observe distant worlds. This marvel of technology will study the atmospheres of exoplanets, searching for signs like oxygen, methane, and other gases that could indicate the presence of biological processes. The European Space Agency isn't being left behind either. Their upcoming mission, the Jupiter Icy Moons Explorer, is set to launch in the next few years. Its destination, the icy moons of Jupiter, including Europa. The mission aims to delve deeper into the potential habitability of these intriguing worlds. Every tool, every mission, every discovery in this ongoing journey not only broadens our understanding of the cosmos, but also sharpens the questions we ask about life beyond Earth. Are we alone? Could there be complex ecosystems thriving in places we once thought barren? Every new discovery brings us one step closer to answering the question of extraterrestrial life. As we've journeyed through evidence and theory, the universe seems less lonely, doesn't it? Let's recap the remarkable voyage we've taken together. We began by exploring the discovery of exoplanets, those distant worlds orbiting stars beyond our own solar system. To date, thousands of these planets have been identified, and many lie within the so-called habitable zone, where conditions might be right for life as we know it. This sheer number increases the likelihood that somewhere out there conditions similar to Earth exist. Then, we delved into the resilience of life in extreme conditions here on Earth. Organisms known as extremophiles thrive in environments that were once thought to be inhospitable to life. From the boiling hydrothermal vents at the bottom of our oceans to the icy surfaces of Arctic tundra, life finds a way. If life can flourish under such harsh conditions here, why not elsewhere? We also discussed the Drake equation, a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. Each term in this equation compels us to consider not just the existence of such civilizations, but also the complexities of detecting them. Through current research and upcoming missions, the scientific community remains fervent in its quest. Whether it's peering through the lenses of the world's most powerful telescopes or sending probes to the outer reaches of our solar system, we are continuously expanding our horizons. The universe is vast and filled with mysteries. Perhaps one day we'll find that we are indeed part of a much larger cosmic community,